Hello, and welcome to the Mr. 50mm Culinary channel. Today, we're doing something a little bit different. I'm going to answer the question that nobody asked. I'm going to answer the question, can you use a V-mount battery to make a delicious instant noodle? Just a reminder, at some point in the past, I did do a video on the Neewer battery, and this was sent to me by Neewer. Thanks again for that. And now that we're done the actual video, I was trying to figure out what other things I could do with this battery. And one day, I was hungry. And even though I'm in a home with a kitchen and a kettle and all that stuff, I thought, no, let's not use those things. Let's try something else. And so that's what we're going to do today. And in a minute, we'll go over the experiment setup. I don't know, the culinary setup. All right, let's get into it. The setup. All right, obviously I have the battery. It is the Neewer PS099E, a 99 watt hour battery. And we have our noodles. So there's still some work to be done. We need to figure out, how do we get those noodles cooked and delicious? Well, because I'm weird, I went ahead and bought a Amazon electric lunchbox thingy. These are kind of weird. They're sold as heated lunchboxes for people that work in spots that don't have microwaves. So think construction sites that are, I guess, very freshly set up. I'm not sure. At any rate, that's kind of the way that they're built. And they are sold for people that want to have a hot lunch that can be heated using the 12 or 24 volt accessory plug in your vehicle. So this particular one that I bought, it can plug in via 12 or 24 volt, or even via 110 volt outlet. In this case, we're kind of going with neither. I managed to connect it to the V-mount battery D-tap, which will offer us something like 16.8 volts. In between 12, I figure that's fine. Now, I know what you're thinking. Hey, this thing has a 12 volt outlet right here. Why didn't you use that? Good question. But I actually tried, and really I should have read the manual first. You can't do that. The 12 volt only offers up 3 amps of juice. So it'll only really give you some 36 watts before the port gets angry and the safety bits kick in. And they work. They do kick in. So instead, the D-tap port actually has a much higher ceiling. It can offer up to around 130 watts output peak. The pack will get angry. It'll get angry if you do more than 100 watts. It'll blink a bit, and eventually it'll take the power off. But as long as you keep it under there, it's actually fine. And this, in theory, is only supposed to be around 80 watts. By the way, this is admittedly not the first test. I did a couple runs trying to figure out what is the best way to power this. But I also actually tried to do this at a makerspace thing, and I got a bit distracted. I didn't check things enough, and it kind of failed. But I think in the controlled environment that is Mabdoom Dungeon, I will pay attention better and we may be successful. So the fun thing about this is there is not, oddly enough, did you know there is not a D-tap to this kind of connector easily available? I don't know if you can see it. There we go. Anyways, there isn't one. So I had to make one. And this is kind of janky. It's a lot janky. But general disclaimer, don't try this with your V-mount battery if you are very hungry and you have one of these, and for some reason one of these, and one of these lunch boxes. Just maybe use a microwave or a regular kettle. They're going to work a bit better. All right, so now we're gonna go to the experimental setup itself. So what I'm going to do is I'm gonna grab this box. I'm going to fill it up with around 2 cups of water, around 480 milliliters worth. I'm going to then put the electric lunchbox in its insulated baggie. This is very cheap, and I'm not really sure if it's going to do anything, but I might as well try to give this thing as best a chance as we can get. And we're going to then plug it into this V-mount battery. Really, the question isn't, can you get things hot and boil it? It's how long will it take, and will this battery survive long enough to get us to a temperature that is at least suitable-ish for ramen. So, fun fact, I already know, I don't think this can get to 100 degrees, like a real true boil. So I'm actually going to probably add the noodles in around 90 to 95-ish and let it cook a little longer. But that should still give us a reasonably nice instant noodle. Probably. This is a very cheap, slightly terrible device. It is basically all plastic all around. There's no real insulation on the actual device. Like I said, there's a little insulated baggy thing. It's also, the heater is just at the bottom. Okay, so for the actual heating up bits, I will use this meat thermometer to generally get a temperature of the water. I'm going to stick it through. There's a little vent hole there. I'm going to just, it's this thing. I'm going to remove it and stick the meat thermometer in there so I can know when the temperature of the water is at around 90. From there, we'll then do the actual noodle making, and hopefully we'll return to a delicious instant noodle. Or just a dead battery and sadness. Who knows? Yeah. All right. Let's begin. Okay, so I figure while we're here and we're all watching the water get hot, we'll do a bit of voiceover. I'll give you a bit more context as to what's going on. So, as I said, the pack initially offers up around 16.8 volts, and we get a pretty steady current draw. You can see initially the pack displays the overpower warning because we're drawing more than 100 watts, but it eventually drops down and the pack is fine, sitting close to 100. Now, one thing I do want to point out is I don't think we made it to 90 degrees. So I was looking out and making sure that the pack didn't run dry. And I really decided to put the noodles in when we had around 15-ish% battery life. And this is mainly because I didn't want to put the noodles in when the pack ran out, because then you would have no more heat input and the water would cool down pretty quickly. This is kind of what happened the first time I did this at the makerspace, and it's what ended up in the test kind of going sideways. The noodles did not cook all the way through. So this time, by putting the noodles in earlier with the juice still remaining in the pack, we get heat still being inputted into the system. So in that regard, it actually will maintain the 80-ish degrees or so. And this is good because then it makes sure that the noodles are able to cook all the way through, rather than immediately cool down the water and leave me with a bit of a half-cooked and half-hardened set of noodles. I also do want to point out a couple things. So when I was doing this, I did do quite a bit of reading to try to figure out just how doable this would be. And looking at a couple websites that already done the math required to figure out how many watt hours to actually get the system to a boil. And for 500 milliliters in general, you should at room temperature be able to put in around 40 watt hours and have yourself a nice boiling set of water. However, we never achieve boil in this experiment, and we effectively almost dump the entire 99 watt hours of this pack into the water, which means that the amount of heat loss we're experiencing in this system is pretty huge, because we put in about 99 watt hours, we don't hit a boil, and really, again, it just goes to show how important it is to kind of have an insulated vessel for this kind of thing. And you might think, hey, but when I boil water on my kettle isn't some sort of double-walled magical device. And this is true because it does seem like the amount of heat loss is actually kind of minimal. So it's small compared to the amount of power that a kettle will output. And or you're going to boil the water much quicker. And the heat loss is basically negligible compared to the heat input. However, for this fun experiment, with the output power being at maximum 100 watts or so, heat loss that is normally minimal for a kettle is going to deeply impact the amount of time it takes to boil or heat up the water in this device, which was kind of interesting to see. And I kind of wonder if I tried this with 2 V-mount batteries and swap them to keep the power going, can I eventually get it to boil? That may be an experiment for another day. Who knows? All right, voiceover over. All right, we are back, and we were successful. Here is the noodlies. So, you might have seen the temperature never really went above 82°C, but that was okay, because I learned from the failures of the past. And I put the noodles in a little early and let them cook while there was still power left in the battery pack. And I think overall, this worked out. Let's have a taste. This fork is terrible. Noodles are pretty good. I think it worked. So it did work. Obviously, I'm eating the noodles, and they are quite warm. Although, yeah, this is really a poop vessel to make it in. Just a minute ago, it was at 80°C, and I feel like it has dropped considerably since I'm now able to consume the noodles fairly all right. So there you have it. If you too are stuck in a place where you have, for some reason, an electric lunchbox, a V-mount battery, and some free time to build yourself the connector, you can make instant noodles, and it only will take you about an hour. And most of that heat, or a lot of the heat, is going to be wasted since you're going to have a lot of heat loss from this poopy device. But hopefully you found this video kind of fun, maybe funny, or maybe now you're just hungry because noodles are great. Either way, let me know in the comments below if you ever repurposed any photo video equipment for non-photo or video related tasks like this. Otherwise, again, thank you to Neewer for sending me the battery. This was a fun side project. Otherwise, don't forget to leave a comment in the comment section and like as well. Maybe subscribe if you haven't already, and maybe a super thanks if you're into that. Otherwise, till next time, bye.